All right, we're back with more DSPy today. Let's see, let's start some background music here. Okay, and let's see where did we leave off last time? Well, we had this. Okay, so we implemented code execution fee. Actually, let's take this, put it here. So a lot of good stuff last time because we implemented code execution feedback for attempting to run the code we generate with AI. So this is done. We also wrote, did we write the new DSPy.Module capable of ingesting feedback? No, I believe yes, right? We did it the refined way. Actually, we wrote a new signature. Is the more right way to say it. So we wrote a new signature that's capable of ingesting feedback and hints, and also has the previous attempt of the model at generating code. And yeah, we chained everything together. It kind of seems to work, but I remember there was a big issue which I'd like to finish first. So let's make sure all that works first, right? So validate that our custom adapter really works. We didn't see it in DSPy inspect history. This is what's kind of worrying me a bit, because you're supposed to see absolutely all the prompts that go through. And I remember we did this on stream with our viewer last time. We couldn't really debug this, although it did seem to work. The feedback, the code execution mechanism definitely works, that attempts to run until it works, but then is it actually giving some text feedback to the model? We'll have to debug that today. Assuming that's done, that's pretty much it. We now have a full, complete DSPy module that is capable of, that's sort of an expert at iteratively solving competitive coding problems. The only thing is it does that in Python, and we had to write a bunch of Python meta code that instruments Python in a sub-process. What we'd like to do is we'd like a module that can solve competitive coding problems in any language. The problem with that is that, okay, so we can change that in the signature, but the issue becomes that the instrumenting the code is not that easy anymore, right? Because to run Python code, we can use something like UV run. But then for arbitrary languages, there is no unifying UV or thing that can run any code, right? Rust can use cargo run. C can just call, C doesn't do much. It just will just run an executable. MATLAB has scripts that I don't even know how to run from. Well, there's a MATLAB command, etc., etc. So what we'd like to do is we'd also like to use AI to write that part, which is going to be really nice. So this is something that DSPy has. It's generally AI that writes code for AI, right? So the fancy way to say it is like self-improving code, minus the loop part, which we'll have to figure out how to do that. So yeah, maybe we'll start that today. This one should be really nice. So let's go back to our, okay. So what did we end up with last time? Okay, so we have to validate that our custom. Okay, so let's finish this first piece because we really need to know that. Let's see, what do we have here? Okay, everything looks good. So first we'd like to validate that we did the right thing last time, which is kind of not as easy as it sounds. Let's see, so if let's run the whole thing again. Okay, so we run it with stream files feedback. So we want to run it with the file system and with code execution feedback. Okay. Was there a breakpoint that we set here? I think we removed it. So we had written this adapter. Oh, not the adapter, the feedback, sorry. So, okay, it is a new DSPy module, but what it does inside is it creates a modified signature, which is actually a class. It's not a class instance, but a class, and it manipulates the fields. Okay, and then it writes this output file, and the goal of this is to be able to run each of the Python files individually. So this one seems to work. Output measurements, runtime, measure time. Yeah, this is not gonna work. See, I think something is wrong here because there's definitely no feedback. And we cannot see the history, can we? Yeah, we can't. Okay, so then we have to debug this a bit. So let's make sure our signature is used. Self-mod signatures. Mod signatures. This is the one that, okay, mod signature. Is this a default dict? No, it's a dict. So if this passes, then we're definitely picking something up from here. Do we ever stop in this adapter? Maybe I should like, okay, I think I know what's happening. Maybe we need to capture history here inside the context. Oh, wait a second. Oh, okay, good. So we're not, okay. So we're not stopping here. We're not, okay, we're not actually entering the adapter. Good. Did we not route this module at all then? Or do we stop here? Ah, we do stop here. What is quarks? Okay, this looks okay. Eek. So what? I have DSPy settings .adapter. Okay, but I never hit the call method here, or what's happening? Ah, because yeah, something is bad here because I can't call the base module. Okay, so we need to look again at how refine does it, because I missed one tiny thing probably. So predict refine is what is the model we used last time. Right, so they have adapter and mod. What is mod? It's just a base module to refine. Right, because you don't want to feed to this guy. I see. So the extra fields are just for the adapter. The extra fields in the signature get intercepted by the adapter here. Ah, is my advice none by chance? Aha, maybe this is what's happening. Maybe we're not building the advice right. Is there a way to disable, let's see, I'm going to get rid of this because it is annoying. Disable quit debug Python confirmation. This gotta be a VS Code thing. Settings, file preferences. Okay. Confirmation. No. Debug confirm. Well, this is never. Disable the quit, you need to modify the IPython configuration file. Okay. So we have to create this IPython. Okay, yes. No, I can't create this. Oh, I see, it's UV run IPython profile create. I wonder where are the settings for this. It's a terminal interactive shell then. No. Okay, we can leave this for now. Let's see. Let me go back to this. Okay, so advice is none. So the first time, okay, we don't want to run the adapter. I see, if everything works in the first shot, and yeah, that makes sense. Now what's happening the second time? Advice. Okay, so we have advice. So we populate all the field name and advice items, advice keys, solution underscore attempts, outcome attempts. are exactly they should be. Okay, so if I go to, whoops, if I go to the next line, okay, so I have my mod signature. Here's the problem. Gotcha. The mod signature is wrong. So what is, oh, I don't see self here. What is mod signatures? And what keys does it have? Self, because this is the module predicting. Okay, but where are the extra fields then? Okay, this is the problem. This is, so. Where are the fields? Does a pen not work how we think it does, or what's going on here? Does it not have output fields? Is this the problem? Mod signature output fields. Does have output fields. Yup, so we should have 10 more fields now. We should have explanation underscore attempts. Okay, fine. So let's, I guess we'll stop right here. Okay, this doesn't work. Okay, we're stopped there. Mod signature now. Okay, so the problem is that this is exactly like signature. Yep, because it's a deep copy. Oh, this is not an in place. Okay. My bad. There we go. This is not an in place. Of course, class methods are not in place because Python does, well, maybe it could. No, it can't work that way, obviously. Okay. Yep, there we go. So you have to store the signature every time, and then we store the last one after all fields have been added. Yep, we start from a fresh copy. Okay, so this fix should solve absolutely everything now. But let's see. If it works from the first try, we'll never know if... okay, it didn't work. So now the... let's see, if we take this mod signature, it should have a ton of fields. There we go. Has a ton of extra fields. Solution attempt, solution outcome, list of code pythons. Okay. I'm a bit paranoid about this list of code python. Okay, good, that's it. So now... Whoops, okay. Now we should have it guaranteed to work. So the feedback, and we should see it in history. That's the main thing I want to see. How much history do we solve? 5 calls. This is enough because we do 3 steps. Okay, what do we have in history? I think this one worked. Yeah, this Oh no, it didn't work. It did work. Oh, it didn't work. Okay, so we failed the test. The algorithm counts how many distinct values. It walks through the array once, including count. Because the inputs are restored, the device information counts. So we have our attempts. Does the test work now? Yes, it does work now. Okay, so this actually works. Wow, good. Yep. We can't see the last fix. Well, this is the last fix. We can't see any reasoning for it because we're not using chain of thought, but that one is trivial. We can just switch the main module from predict. Okay, let's see that in action. So let's use, here's another thing about DSPy. You can easily enable, I wouldn't call it reasoning, it's sort of verbose reasoning that you can capture in the signature output with this chain of thought, which what it does is it will force the model to also output a reasoning field. May not be the best idea these days because a lot of the bigger API models, they have internal reasoning that they do, which most likely may not expose. So then if you also ask for external reasoning, it's sort of like double reasoning, or you get explicit reasoning, but it should be fine though. Big models are powerful enough. But then for small models like this one, that the free the free Nemotron we're using, definitely okay. So now we can see this one is nice because let's see what happened in the first attempt. So we got here. Oh no, sorry. So these are the system instructions, right? There's an interesting caveat here that this is a variable, not a function name. Okay, so this is the problem. Okay, so you see this reasoning field, which is quite brief. The problem asks for a number of distinct because you're able to approach learning time set based. Okay, the model does something. Now, let's see. It didn't work. Now it gets to the 10 input problem because something wrong happened with the previous solution. It also sees the previous attempt, runtime attempts, solution outcome, and let's see what actually sees. So there was an assert. Okay, it failed on an array. Now, what did the reasoning say? And I wish there was a way to view word wrap this. Okay, the previous solution returned length and which is in it. However, the test case is expect the result to be a list. Okay, so the model can clear. This is why this fails, because, and this is explicit execution feedback now. So this is pretty nice. We are done. Everything runs. We don't know that we don't really see in the history that everything runs, but sorry, not main. We can run the test and it actually runs. Now, what happened here? Why is the test not? Okay, there are no prints in the test. Interesting implementation choice. Yeah, this makes sense because this bracket here, right? This is what the model's doing, because if we look at what test cases we're feeding, there is a bracket just for us to accommodate possibly multiple outputs. Okay, so we're done with this. Good. Very nice. And we are left now with the big work, which is, okay, we did all this stuff. It's kind of, let's take another look whether it's really modular for Python. Well, first of all, let's see, do I see any Python here? There's one mistake here. So first we need to modularize this to make the code ready for another language. And I already slipped a mistake in here because we did that last time. We parameterized language, but I forgot a hard-coded Python in the signature. And I think there's an interesting corner case here. Doc string, the signature, the description of the signature is the doc string, but it doesn't work with F strings. Let's see what happens here. Maybe this is different in 3.14, but I don't think so. There's a trickery here. Because this evaluation needs to happen when the class is defined, and I don't think it does. Okay, so everything worked, but let's look at the doc string. Where is the, sorry, I'm missing, oh yeah, there is no doc string at all. Yep, this is the problem. You see how my thingy here, if I type here, blah, 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 I actually completely wiped the doc string. So this instruction does not appear to the model will never see this piece of prompt at all now. Which is not what we want. This is very deceiving, right? Right, and the reason for that is F strings in class doc strings Python. They are not recognized as formal doc strings. Which bypasses the okay, because they have to be static strings. Okay, so how do we do it? Well, we can do a doc, assign to doc, you can find the rank spaces to the doc attribute after the class is defined. The most common is to keep docstring and use the standard docstring formatting. We need this sort of formatting. String templating in docstring Python. Cannot be generated in T strings. Can I not use T strings for this? This docstring will be replaced. Okay, so let's go back to our example. The blah blah is not there at all. Yep, it's not. Okay, so this is the problem, right? Okay, so we wanted to say this, but we can't use this. Okay, I think this can be fixed. I'll be right back. All right, we're back. And okay, so let's before we fix the doc string, let's let's push the new code that fixed the issue. What was it? UVX rough format. Nice. Actually, we should git ignore this history.txt, right? Where is git ignore? We should just ignore start.txt. Well, no. DSPy helpers. It should be history.txt. Output. And we can ignore this one too. Well, actually, we don't even need these anymore. These were old examples. Okay. Okay, and then what did we do? We worked in feedback for now. Yep, there we go. This is the fix. Get commit dash correctly derived new signature. There we go. Okay, so that's done. Feedback is done. Now we're fixing the language in the F string. Let's take a look at. So one way to do it is here. RT. Let's see. Can T strings be used as doc strings? Python. Nuh-uh. Yeah, okay, so there's kind of no way around this. Maybe the signature, I believe it does have, so it has with instructions. Return new signature with identical fields and instructions. Constructs a fresh, yeah, so it's basically what we can do is, but it breaks this though. So if I put it like this, is this called something in Python? Evaluate brackets in static string Python. I think this works. Okay, so it's dot format, so you can leave it something empty. So it's string dot format. Okay, and does it have named fields too? The thing is, we have to do it this way. We have to override, which is with instructions. Problem solving dot doc. So what does format have? Self, literal string, args, quargs. Oh, I think, okay, so maybe it works. Okay, we need some docs for this. Python string format method. Aha, here it is, the first P. Okay, so you can put something, but how do we give it the dot? Yeah, so this is what we want. This food is adjective. But it's even worse than that for us because I can't say this. So I could do dot format, but I can't do args dot. Okay, so maybe what? I have to unwrap the dictionary then. Wow, really? I don't think this works. Maybe it does. No, it doesn't. Whoa, whoops, sorry, doc. This one is easy. Well, actually, now that we're here, we can just try it. So, yup, and what I can say, first of all, this is this even Python? Yes, this should be Python. It's just unwrapping, well, yeah, it's just dictionary with the string Python. So then if I go this, is this valid? No, because it tries to reach into args. Right? It's not a new line thingy. Yeah, so the dot notation is not gonna work. I can just call this whatever, then it doesn't matter. Now this should work, right? Yeah, and I don't need this. I need language args dot language, and that's it. Did I actually change anything here, or what is happening? Oh yeah, okay, we should not change that for now. Yeah, okay, everything works, and if we look in the history, we probably have the... Okay, so now you're an expert in algorithm problems using Python. So the string was correctly replaced using dot format. Okay. Okay, it's not the cleanest tool. Yeah, it's because Python doesn't let you use... We can't use F strings at all, but... Okay, so this is part one. Okay, this is a tiny fix. Let's see, git add. Now what we want to do in order to work towards our goal of actually handling arbitrary languages, fix language in signature. Okay, we're good here. Yeah, I think we should be good, right? Because we deep copy. Oh, whoops! I have to do a git pull before. Okay, because I added the license last time, which is MIT. Yeah, because from this point onwards, this is frozen, so it's fine. Our feedback, what? It copies this, deep copies the signature. It's not going to touch the instructions, which is okay. Now, so here everything is modular. In this file, okay, it's kind of modular, it's kind of not though. What about these files? What about the project structure in general? We want this to be fixed, let's say. This Py extension is a problem though. The dependencies are okay. Because they are used in let's rename this to project.py. Okay, so we'll do git add src stream project, git remove src stream adapter, and we also need to change some imports now, right? From stream.project project. Let's see, does it work? I think we want to separate this one more time. So let's go back, but before we do that, let's fix the py here. Well, what if this file just has no extension? And what if the project... Okay, so then we can just have project. It has the language and the files. It's easy, right? We just do a... Okay, so first let's rename submodule to better name. Okay, so this is done. I think what we want to do is we want to get... I know we just need we actually don't even need that py because we use .stem a lot. Yep, we use .stem almost exclusively. The last part. So for example here, what is the location? It's a full file path. Yup, and what are the parts? Well, okay, I messed up here because location.parts. Here they are, okay. So then if I take, let's say that other is path. We have path here, right? From pathlib import path, yes. What if I would have called this output cases? Okay. And what if I say other.parts? List of this. Same thing. I don't even need the stem actually. Although I can get the stem. I think this is better. So let's store the files without their extension. And then let's also have a small interesting. The file is not aware of its language. So actually this is should the file be aware of its language? Because what I want to do is, okay, so this is pretty good. So first and foremost, we can, if we ditch this, okay, everything should still work, except for one part, the part that here, where we write. No. So who writes here? Sorry, oh, I see, we write now. Eek. We made this write to disk, right? Because we have a write code. And to where does it write? Prediction to the project. I see. So for name and prediction items, file map. So we would have to change this, but this is fine, right? So actually, what else do we use file map for? We use it for a location. Okay, we don't need the dep here. For dep in depends on. Yeah, I think file map, we just use it to I see. So to execute, we also don't need the name in the extension in Python. But then, yeah. Okay, so then we can just have a property with extension is false, true. Okay, so then we say fpath if with extension else fpath. Okay, and what do we want here? Fpath. How do we pathlib add extension with suffix. So we can say with suffix. Yeah, the initialize also depends on pi, actually. Interesting. So then we can go if, well, if we want to use this as an example for the LLM, then it should just be py. Do I have to use the dot? Okay. So then file map with extension true. Okay, this should be it then, right? Rough format. Format. Okay. So it's fpath if with extension else Now this is true by default, so... Oh, can I not use this for... No, it's a property result. Okay, then I'm not gonna cache this, right? Yeah, this is fine. No, we want this. Hang on. How do we... Can a cached property method take args? Sure, we can use a cache. I wonder if this is the most idiomatic way to do this. So this we definitely can't do. The problem is it changes the call pattern now, right? Because I have to call this as a method, which we kind of don't want to. So then let's see. So what is this file map? Ugh, I hate this. Nah, we should rather, I would rather actually copy code here. This doesn't look good at all then. Let's leave it cached. And then just have it be 2 versions. So the file map is okay, and then we can call it interesting. This is more for the AI to work with, but sure. So then this guy is with the suffix, and then this guy is without the suffix. Everything is file map is still the default, except in some places we can use the module map. And let's not keep this then. Let's actually do it. Okay, this is how we do it. So now everything is backwards compatible. And I can just run the thing. Now, if in some places well, actually now we're done because we removed the pi from here. Okay, good. Okay, so we don't have PY here anymore. Whoopsie. Is this a random bug or is it something systematic? Let's see. I think this is something systematic. Now something is crashing here. Okay, so that means we do use something without the file map. Yeah, we probably reach into... Oh no, this looks fine, right? Interesting. -m output.test. What if I remove this? Just gotta make sure nothing weird is going on. I guess sometimes DSPy just doesn't obey, right? Or the models don't obey the DSPy signature. Yeah, this seems to be in order, I think. Yeah, as long as I can definitely run this. I cannot run this. And that's because why? My feedback just blew up. Oh, I see it tried 3 times. List is not, object is not callable. So what, here in test it fixed it by accident, right? Yeah. Then something asserted. It's actually not the worst because okay, well, here we just got unlucky then because the AI kind of oscillates. There's nothing really we can fix here, except the real fix is a bit different because it has to do with the AI not knowing how this file is written. And also our adapter calling it function name, which is wrong. Yep, here it is. I wonder if, yeah, something like, okay, so first let's, So we disentangled a bit more. No, we don't need the func tools actually. It should be cleaned up. And this is disentangle language from main. Yeah, a bit more. Okay, so now we have the main disentangled even more. But actually, that case is really nasty because the way it's written to file, doesn't tell me anything. Doesn't tell the model anything at all about how it's written to file. And this is also leaking Python here. Aha. This is leaking Python here. Okay, so we have this piece, which is Python specific, because this equal symbol, like, this is not going to work in Rust because it needs well, curly braces. Well, not curly braces, but like nested brackets and semicolon. Yeah, that's not going to work at all. It's not even type annotated. Okay, so this is one part that needs... This is the last piece here that needs generic. It needs to be made more generic. Genericalization or something. Genericization. Then the other part is the execute code. Well, let's look. Okay, so let's do it this way. Let's write a new module, which is called language.py, which sort of collects all these pieces and standardizes their APIs. And you guessed it, this is what the AI. So, okay, so ideally this file should be written by AI. And then our DSPy code just imports from this file in the actual main DSPy code and in the submodules. Perfect. So we just gotta go one by one then. So we found a piece here, right? So something like this will have to be functionalized. And this will have to be turned into a function called write arrays to file. Okay. Arrays. Now we have to standardize this. The fact that they're lists of integers. Because even in the meta language approach, it's just not going to work without this. Well, I guess it's this monstrosity though, right? So it's not a list of lists, it's a list of two lists. Well, oh yeah, because it's a list of cases. Okay. Okay, so then it returns none. Okay. So then, and of course, the most important thing is let's take as input the language. Yep, it's a string and it's Python by default. Okay, so then what it does is it says if extract inputs, and so this one writes a multi-dimensional array. Okay, so write a single multi-dimensional array. So it's write array to file. And it says we don't need a key here anymore. We just do with open. Let's just do a gigantic Python then. So if language is Python, or let's not make this depend on the language. So it's gonna open file name path, okay? So it'll be open file name with suffix as f, in write mode as f, and it'll do f write. Oh my god, I need to know the... Okay, but the key is easy, right? Because it's file name dot stem. The variable in that file, the array that's being written to disk, will be called exactly what the file is. And it will be written in a file with the suffix appropriate for the language. And the sentence will read the variable name, which is the stem of the file, is equal to... For Python, it's the array. And we're done. This is one piece. So now I can say like this. I can genericize this because I can go here and I can say from stream.language import write array to file. And I know I need to write, well, I can actually keep this. So for key and written inputs, write array to file, what do I have to write? The array is inputs of the key, and the file is exactly the file for the key. And that's it. I don't need the suffix. Okay. These become so interdependent now, right? Okay, so now I've removed, phew, okay, I fixed this fixed me. Well, not this one, this is something else, because the signature is still not aware that this will happen. But I've removed another Py hard coding and I've moved it to this file, which is our first sign of progress, actually. Yep, so with open array. So let's see, does this work as we think it does now? It should. Okay, it starts to get hairy though because, well, no, because if all the dependencies will be moved here, yep, the AI's job will be to populate the contents of this file. Seems to work. Yeah, it did work, right? So it at least wrote the cases exactly how it is. Now this only works for Python though, because I don't know how to do this. In Rust, it's gonna have to be a proper 3D array. Rust doesn't have brackets and parentheses, or C for that matter. I don't even know how to write arrays off the top of my head. So there's still a lot of work to do there, but that's the point. We want the AI to do this work because we're not going to write this for all languages. So now you can see, okay, this is the point I wanted to make. Now you can see why this is tricky because, okay, I can add a language here, which is a string, okay? But if I as a human have to start writing all of these, okay, I can do it for Python. I already don't know how to do it for C. Maybe I guess the open is universal, right? Because assuming all the other pieces were there. This file name is already wrong because it's also hard-coded as py. But that's fine. This will eventually live in this language-dependent file too. Assuming that part is fixed though, it would still be open, I guess. Maybe this open really is universal. So maybe this part is not that hard, but I don't know what to write here because I would have to write. So first I have to write an int. Pointer. Right? Because it's a, yeah, so it would be a int pointer to a to this. Or no, it's actually it would be a, I think it's like this, right? Okay, so I would have to pre-calculate the size. Which would be like, the size itself is a bit more complicated because it's a nested array, but so sizes would be, so we can mess around with this. So it would be 2. No, it wouldn't be 2. It would be length of array, then 2, and then length aha. So I would have to split the inputs. Yeah, this is a bit more complicated actually, because I can't even write C doesn't have jagged arrays, right? Why, yeah. So it would be the array of 0 of 0, and then size outputs. This guy. And then you would write something like inputs, and then the sizes would be all of them. But then I don't even know if I don't even know how multi-dimensional arrays work in C. C multi-dimensional array. Oh, it's with curlies. So I don't even know how to do this operation. How do we do this operation? We have to turn all the... Ooh, yeah. This is gonna be... This is what we want AI to do. Yeah, this is kind of... I'm kind of showing the problem here because... Okay, so we're gonna have to work with curlies somehow. And it would be what? Okay, so it would be a string. Yeah, so it would be inner arrays. Also, the size of inputs is not, it's like this, it peels off the dimension of 2, right? Yeah, so for each input. So then you would have to write the inner arrays first, which is a list of F strings, and they're all the actual curlies, okay? And then here the values are a list comprehension element for element in array, and then the external list comprehension is for well, let's call this inner array, for inner array in array and 0. Ah, yikes. Yep. So these are the inner F strings. And then what you do is you write to file the following statement. Inputs. So this has 2 size inputs, 1. And then it is, you have to join these. Wow, this is so bad, right? Because you have to join these, yep, join, and you join them with a space, well, with a comma space, dot join, okay? So then you glue these. And you can finally write them in curly brackets. Yeah, so you need a curly here and a curly here. Pretty messy, right? And then we go again. Then we just write, well, oh, sorry, I forgot one thing. C is semicolon, right? So I have to end each C line with a semicolon. So I have an int vector, C multidimensional. Yep, it's an int matrix, or, right? Yeah. Okay. And I have to do exactly the same thing for the outputs. Except, so it's here, and size outputs 1. And maybe I just write like a separator line, f dot write. I definitely need to write a separator line. Well, no, because I think C statements work on the same line, but sure. Okay, so then we can do, let's see. If name is main, let's try running this. Cases equals, I'm just gonna take the cases, right? Here. Which is exactly my Python list of tuples of lists. And let's see, did we nail this or not? Very likely, and I'll just say file name is test.c, okay? And language is C, and then we can just call write array to file, cases, file name, language. Okay, so let's see. If I do now uv run -m stream dot language. Oh, whoops. It's a path here, okay. So it's path test.c because it wants a path. Okay, we wrote a file. Mistake, because okay, so almost there. 3.6. Oh no, it's still jagged. Wow. I don't even know how this is gonna work actually, if this is jagged. Jagged arrays in C. So we have to do arrays of pointers. Then I messed up. Yeah. What about in Rust? Yeah, it's a vec. It's actually a lot easier. Oh, bounce checking performed at runtime. Interesting. Okay, but we have to, yeah, so I kind of, well, anyways, you see the point I'm making, because we got pretty hairy pretty fast here with the C. Now the question is, can we get AI to write all of this? Yes, but there's one more final problem that we uncovered, which we have to address, is that, yeah, the signature is not aware of how this will be written. So I think the right thing to do is we need to make this DSPy.code, okay, of the language. The paired inputs and outputs for the problem. So code defining so it's, yeah, it contains, we don't need to say code because we're using DSPy code. So this code file contains the paired inputs and outputs for the problems implemented written as jagged arrays. I think this information is needed, otherwise it becomes very tough to do anything. It's already pretty tough, to be honest. Yeah, we have to do it this way. Okay, so now it takes code. So now we have to first write the code. Okay, then we'll just define the cases, the test cases for the problem, jagged array. So the cases will be pulled out to be a variable, and that's it. Then cases now will be, first we have, okay, so now we write, okay, now we really fix the fix me, right? Because now we write just the raw, we don't need this anymore, and we actually don't need this at all. So we just write cases in the language to the file. And I guess we'll have to hard code this one. Yeah, so cases will be cases for now, because yeah, this can be genericized, but I think just dealing with one is enough for now. Okay, so we write the cases. Now we can say the cases is not the variable, but it's the code. So it's actually read dot what? Read text. Okay, because this is a path and we read from it the code in the language and it gets fed as an input. That's it. Yeah. Okay, a different story now. So now the language, this is still importing from language, which is great. I guess we'll have to leave this out for now. We don't want this. We don't want language in the API, right? I don't think so. Interesting. Do we want language? No, I don't think we want language in the API. No. So we just want this to be for a specific language. And now it's for Python. Maybe we can store this somewhere. I don't know. It's mildly useful. Probably not. So then we just do UVX format again. And if we run everything, it should work. No breaking changes. Yeah, it has to be this way. Otherwise, it's too entangled to not have the core AI module be aware of how the code is written, but still have another AI module write that code. Maybe I'm thinking wrong. It could also output some brief explanation. Okay. Yeah, so there is but then the... No. Okay, this actually also will significantly fix test, because now it'll know what to import from the first try. Okay, no, this is it. Yeah, this is how it has to be done. All right, quick break. We'll be back with more. Okay, we're back. Okay, so this is actually starting to look pretty good because we'll speed up significantly. So okay, this all works. So now we managed to finally separate out. I'm just gonna delete this. It's bothering me, and we don't need it. And we'll see why. I had some other ideas. Okay, so now we have, okay, so let's add this new file now, or let's add the changes that we did. We don't need test.c, and we just need to, what did we change? Yeah, we just took this thing and that. Okay, we also made the case and we're using that thing. That's it. Okay, good. So git add src stream main src stream language. Move language dependent components to a new module. Okay. More. We need to move more things in here. So I think main is 100% clean now, right? There is absolutely nothing here that says this is Python. We can even remove this comment, right? So it's just the project structure, which is a set, a mapping between some strings and file objects which have a path without an extension. So we don't know if this is Python. The files also have dependencies. Again, we don't know if this is Python. Many, if not all programming languages have dependencies. The project has a language. This can be anything at runtime, and the files. That's it. Then the project does an initialization function, which we don't know what this does. Not in here, not in main, okay? So right now we're just walking through main. There's a signature which talks about the language, code in some language. There's a concept of jagged arrays, which is universal enough, I would argue. There's the concept of execution, which is universal enough. Inputs, outputs are universal enough. Profiling is universal enough. Testing is universal enough. There's some back-end manipulation, which looks ugly, but whatever. I really wish this would be... this can't be fixed. The module that solves, there are the cases that are being written to a file. Now the cases, they're just integers. It's like the signature already says, we already know what this is. So this produces this code file. We don't know in what language. This function decides in what language. And actually, is it stem here? Oh, yeah. Sorry. So this file name. Oh, okay. So there is a project structure .file map, which we don't see here, but it does have language info, but there's nothing telling us this is Python. It writes this file to something, and this function already assumes that this file has the extension. This is important, right? So file name already has extension here. With extension. Let's call it more explicitly, right? Instead of adding a comment. So it's with extension, but this is still this is still fine. We can finally kind of sort of guess this is Python just from this line, but this is fine. We're back to main. Then we have the inputs to DSPy. Nothing telling us this is Python. We read the cases code, which, let's see what this is. Oh, here we go. So it's whatever code was written here. We get the prediction, we save it. That's it. We're done. Okay, so we finally cleaned up this file. We have 2 more files to clean up. The judge is a toy project we did last time, so we're not going to clean this one up. Let's clean the project structure. This is the big one. It's really, really big. Okay, so we need to remove all traces of Python from here. The file itself has a path and other files it depends on. There's some mess here because do we work without extensions or with extensions? Well, the problem is that depends on like this is gonna lose the extension here. But when we add the depths, it's without extension. Interesting. We do have a problem here with the extension choice. This seems like it should be fixed sooner than later. Do we even need this with depths? Doubt it. Yeah, this is a deprecated method, right? Yep, I believe so. So this is toast, which is good. Not that it does too much. We have a bigger problem on our hands because we need to decide. This is going to confuse the AI because we're exploiting this stem here. Because for Python we don't need an extension, so we can get away with the dependencies not having an extension, but they'll never have an extension. The thing is, I don't think it matters. I think stem is... No, it does matter. For C, you need to know exactly the file name, for example. You can't... Oh, okay. So then, you know what? Oh, boy. We have a problem now because... Should we do this? It's a post in it, like, but then the file knows the language it's in too, right? Or I can just do this with, yeah, I should do this, right? With suffix .py there. Yeah. Yeah, okay, we should do this. So everything is stored without extensions. But all the project properties are with, they always reference things with extension. I believe this should still work. Let's do it this way. Otherwise, it feels bad to have each file carry its extension around because we're not doing cross-language projects yet. Although this will be a big problem with C because C has .c and .h files and it'll have to be .c files only for now, which is fine. That still works. Like you can include C files in C, right? It's not like it's some magic thing. Okay, so let's see what's happening here now. Yeah, so what's happening here is that the stem is the key always, and then both for the dependency map and for the file map, yeah, these are full paths. Including the extension. Okay, so now the reason why I wanted to get here is that this thing does not depend on the language at all now. But the whole project does. So then we'll say from stream.language import project. This guy has to go. There is no way you can be here. Okay, so we just found our second thing that depends on, and this guy has from stream, there's a circular import here, which is fine. Let's see how this goes. Dot project import file. I believe the way to break it is like this. Maybe not actually, maybe this is fine. From data classes, import data class. From func tools, data class and field we need. And from func tools, import cached property. And we need OS. And from pathlib, import path. Okay, that's it. So UVX rough format. UVX rough format. Rough format. Okay. So now we have our project. Is it not from stream.language? Why is it not showing up as green? We don't need cached property here. We don't need OS here. We do need data classes here. Okay. UVX rough format. Okay. So if I try to run this again, there is a circular import. And the only way to break this now is one of these guys has to give, and it has to import the thing. This should work. Yeah, this breaks the cycle because this becomes a... Ooh. Do both of them have to break the cycle? Oh, seriously? No. Okay, well, I have to resolve this in a clean way. So Python resolve circular import. Pythonic wait for the circular import statement. This approach depends on refactor. Nah, we don't want to into a new separate common or shared module. Both original modules can import for this. We can defer the import. Yeah, so we need to redesign some stuff here. So let's think about it. I could move this into, no, but we don't want to move it into language. Now, project is badly named, I will say that. I guess we can make a utils, right? Which will be like the, yeah, this should be the absolute one. So then it'll be from data classes, import data class field, pathlib, import path, and that's it. So then this guy will have, and then this guy can do stream.utils import file. Yeah, we have to break it like this. Okay. Oh, actually, we don't. Oh, we don't even need this? Oh. But we still can't have it. Oh, I see. So then it's in a bad place for sure. Yeah. Yeah, that's the thing. This should be, this is the twin of project, but it's not language dependent. So we don't want it here. Okay. And then this guy becomes from, okay, so then becomes completely different. It becomes from stream.language import project. And from stream.utils import file. Okay. Okay. And let's see, this should be enough to get it to work. Yeah, if I make the file a sub thingy here, I could have a subclass here, like a nested class, but then maybe I should. But then do we? I think we do want this because this file, if the AI is going to write this, this file should really be self-contained. Okay, that's fine. We're refactoring once again. So what we do is we take all this thing, and I believe this works. We'll tell the AI not to touch this. We'll have to talk about that too, by the way. Like, how do we tell the AI not to touch something? This thing is gone for good. It's never there. Now, yeah, we don't have this import. Interesting. Interesting. Python nested data classes. No. So defining data class inside data class. Seriously, we can't. How can I use the type annotation? Because this, no. We actually want nested things though. Maybe this doesn't work in Python, right? Inside the class then. It does work. And this is exactly how I want the behavior to be. So what's the problem? I don't want the outer attributes. Yes, this is true. Inner class defines a normal separate class. I think this is correct though. Definitely seems like we have this pattern here, right? Files would never be used outside of the project. Type request is a namespace. Yes, we want a namespace. Okay, but this seriously, this, okay, so I need to learn more Python then because play.py. So you're saying I can't have, oh, it's just a type annotation thing, right? If I do this, I bet it'll work. Nuh-uh. So then I can say stuff like what? X or file is project.file. Yeah, this works, right? So path sum path.py. And then what's the other? It depends on empty. And what? -m stream.play. Well, this all works nice and fine, except the type annotation is broken. Actually, I don't know how to fix this one. Interesting. This guy has visibility, but the inner data class doesn't have visibility into itself? Huh. Let's, this is an interesting one. I thought Python 3.14 would solve. It seems that even in Python 3.14, classes defined inside another class can't be used to self-type annotate like below. Is there a way to correctly type annotate the internals of file using the class file? The first evaluation of the specific way class scopes. The issues that will follow, it isn't yet in the local namespace. Aha, okay, of course. So the type checker of runtime cannot resolve easily, especially when it's nested inside the project. Yeah, this makes sense. The two ways, the self type preferred for Python 3.11. Okay, so I can just magically call this self. Yes. Okay, where do I get this from? Oh, interesting, from typing import self. This file here is wrong. Okay, so I can magically, okay, this is kind of dirty, but fine. Okay, so then let's go back to our thing here. So what we want the AI is to, okay, so now let's finally go back to our thing. So we extracted more language dependent things from our project structure. Ideally, we would like the AI to manage all of this for us. So it'll have to generate this code. Now there is Python specific things here, like for example, the fact that modules are in __init.py. This is highly specific to Python. And what we ideally, we don't want to start writing like if language is Python, then do this, blah, 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 because there's like hundreds of programming languages. Instead, we would like the AI to generate this code at runtime, fill it in the project, and then we have our other AI module, which is the real AI module, which is supposed to solve competitive coding problems in the given language. But now with the code execution infrastructure already generated by the first AI, in case you joined later or you just joined. Also, if anybody wants to ask questions in the chat, feel free to do so. Okay, so our job is to isolate all Python-specific pieces of code, or let's say we need to extract from our current project all instrumentation code that runs code specifically in Python. Okay. Now so we did that for main. Now let's move on to the project. This function writes code given a project structure, and there's nothing Python specific here, so we're actually good. Okay, clear. The big one is the file adapter. Okay, so this is a prompt generator responsible for generating prompts that are related to what kind of use or import statements should be used for the code to be valid. And remember that we want our AI not only to generate a solution to a competitive coding problem, but we also want it to generate code that evaluates runtime complexity and memory complexity, and also test code. So then in earlier streams, we sort of built all these dependencies, right? Because in Python, they're called import statements, right? So you want to do stuff like in the test code, you want to import the solution. Otherwise, you don't want to redefine it here because you're sort of leaking logic. Same for for measuring the execution time and usage. In these functions, you also want to import the solution. You can't just redefine it here because that may be different. So this part worked. The problem is we had to generate prompts that tell the AI, in this file, use this type of import statement. That part is Python specific because even the concept of import is related to Python. Other languages like Rust, they have use statements. C has include statements. So, but we kind of knew this and we sort of wrote this adapter not too bad. So let's see. So it does a process signature. This is fine. There's nothing Python specific here. Aha, here it is. This is the key piece. So there is a magical function inside this format output interactions, which is called helper function that generates a language dependent use statement. So it takes as input, this is wrong. It should be a path. Okay, it's wrongly annotated, first of all. Yeah, okay. So it takes as input a path to a file and the language of that, well, the language in which we're operating in, and generates a so-called import statement, but we only have it written for Python. So definitely we need to move this function in the language part of our project. This is critical, okay? So now this is gonna be generate use statement. We can trim the language now. The only sensitive issue here is the location of a file enough for most languages? And I will argue that I think so, right? So even in C, because you have an include statement. So in Python, of course, it is enough because this is what we do in Python. We split the location in parts and we generate a string that says from space, the parts join with dots, import function name, which is exactly how something like this is generated. From output.solution, because here the path is output.solution, the file, import, we don't know the function name before the AI generates it, so we have to use a generic here, but it's fine. Function or variable name is more accurate as a prompt. Okay, so this is genericized now. This works. I mean, this happens to be implemented for Python, But now we can magically ask the AI to rewrite this for any language. Let's go back to where we need to use it now. So from stream.language, we have to use this function, generate use statement, which now takes only one arg. And I believe it's already used somewhere. Oh yeah, we have to cut it from here. And where is generate use state? Here. So it doesn't depend on the language anymore, because we're gonna regenerate all this code for a specific language. Okay, so we just generate the use statement and we cache it. Now this concept of adding it to instructions, yeah, this is generic enough, right? Because we want to instruct the model when you generate code, write this use statement, which I think is fine. Let's see what's happening here. W, okay, this is frozen. Okay, we have an error. Oh no, we don't have an error. Okay, is there anything else that's Python specific? No, here we use a generic language. Okay, this rough format. Okay. Output instructions we put here, which is what we just changed. Okay. When generating, there is something else. Use the following. These are no longer called import statements for something generic. They are called use the following. I would call them the following code to include. No, use the following code to include code from other outputs to reuse other outputs. Is the concept of import universal enough? Not really. C has includes, right? I think the concept of reusing code is more universal. Okay. Basis is fine. There's nothing about Python. Okay, I think we're done here. So now we isolated more. Okay, this is actually starting to become manageable. Now the other final module is the feedback module. So this is responsible for executing code and pasting the feedback back to the LLM. And this has to be generic now. So let's see, did we make any Python assumptions here? Signatures, no. Project, the project is still the project structure, which is generic. Steps is fine. These are all DSPy-isms. Deep copy signature, only for DSPy code outputs, this is fine. Insert trajectory, previous attempts. The concept of attempting to generate code is generic enough. Doesn't depend on the language. It's for this language, generic. Execute code, here it is. So this is a method Does it depend on self at all? No, good. So the way we execute code is with uv run -m module name, which obviously will not work for any programming language except for Python. So then this thingy here, so let's see, where do we use this? Okay, so we only use it once. Now, so what arguments do we need to execute code? We need a path to an artifact, which I think when I wrote this, I kind of already had this in mind. So artifact is a generic concept in code, right? For Python, it's a module. For C, it's a compiled executable or library. For Rust, the same. For MATLAB, it's a script. Generally, to execute code, you need a path to something. A file. I think that's a sane assumption. Now, whether it's a build file from some instruction, maybe we need a build command too. So maybe we need so we want to genericize this, right? So first of all, we don't want it to depend on the language. Or rather, we want to make this for a specific language in a way that, let's see. Okay, so we don't need this. It's not self anymore. So it takes the path from artifact. Let's not depend on language. So now this will be for Python. We need a subprocess. Subprocess is universal because we're gonna have to run code in Python. In this case, it happens that we run Python code in Python. We just spawn a subprocess, but that's fine. No longer depends on language. So it has a success message, which is the DSPyism. So now the question is, do I need anything more than a file path to execute code in some language? I think here for compiled languages, we may need a build command. Or what? The AI is magically gonna generate it or do the build here. String or none is none. I'm tempted to do this. So success message. String or none. Whoops, sorry. String or none is none. Maybe this should be a pre-command. But then why would we pass? No, because this is not going to be possible, because now we're going to have to define the pre-command when we call the function. Nuh-uh, which is what we don't want to do. No, I think we're going to have to let the AI magically do all the pre-work inside this function. Just given a path. I think this is a good experiment. We'll see how AI does here. I'm not sure it's possible in all languages. Like in C, you need a build system. So at least you need a GCC command or a C compile command. So I guess you need a compile command for each path. So maybe this can look into the project. Okay. So maybe this thing has visibility into the project too. And we have depends on for each file. Okay, we broke the code here, sorry. So there's no more file anymore. Instead, it's project.file, which is fine because we're using this as a nested class. And I think that's it. Pretty clean otherwise. Yeah. Just this guy use file? No, it doesn't use file. Oh, does this guy use file? Nope, it doesn't use file at all. Good. Okay, we're back here. So yeah, so I think this is optional. Parse the project to figure out any, if at all. So then what we can do is we can let the user, we can pass the user responsibility to improve the project structure in general. But then for any language, it should have enough info in it to sort of figure out how to execute a specific file in a project. So for C, those are called compile commands, right? Because you can run GCC, but you have to include other files. For Python, nothing else is needed, because with stuff like UV or Python-M, you can just run a file and all the dependencies are at runtime evaluated. Yeah, I think this is good. Yeah. Pre-commands required for running the artifact. And I think AI will do a decent job here. Okay, so let's see, where is the import we need? So we need from stream.language import execute code. Because now we want to execute code. And what, this is not used? Oh no, it's used as self dot. Okay, so we need to nuke this from here. Okay. Whoops. And we just need to use execute code. No language, but yes to project. So artifact path success message and project. Do we have the project here? You would, oh yeah, we do, perfect. So self.project. Actually, this should have been how we do it anyways. Okay, this looks pretty clean. Okay. Rough format. Now let's check something. Does our vanilla behavior still work for Python? I think it should still work. We didn't break anything for Python. We just removed the language argument from everything, but it's still hard-coded for Python. But we're very close to rewriting that file with AI now for any language. And then hopefully it's pluggable, which should be pluggable because it's just one Python submodule in our instrumenting project. Okay, this seems to work now, right? And yeah, it works. Everything still runs in Python. So output.test. So we have, there we go. Run times, memory usages for the problem we solved. Okay. Pretty clean actually. Measurements, whatever. Good. Moving on. Anything else in feedback that's specific to the language? I don't think so actually. We're very close now to finishing. Attempts are universal, outcome is universal. Writing code is universal. Yeah, it is. We just write code to files. With extensions, right? Because we look into, oh, this should be project. Yeah. If we go into file map, now it is a language dependent thing because we add the py suffix to files. but that's fine. It's isolated in the language submodule. Moving on. Attempts, this is fine. For code up, it's fine. Executing code. We get an artifact path, which includes an extension at this point, but we don't know what it is. It's fine. Executing code itself, we just get a message back. We have no idea in what language this happens. Fine. If it runs, if it doesn't run, we already failed. Otherwise, blah, blah, blah. Store attempt, tourniquet trajectory. That's it. We're done for good. Okay, so this is a giant rework now. So we can do UVX rough format. We can upload all this to the GitHub as usual. So let's see, git diff. Let's see what did we change again. Rearrange some things. Yeah, we definitely mess with the project structure. No, we just modularized it a bit. Okay. So we want to add stream main, everything, right? Language, feedback, and project. And we're gonna say this is the big commit. Isolate all language specific code in stream.language. Okay. Pretty good. Okay, so now let's actually use DSPy. So what we want to do is, here in this file now, do we want to write the module here or another meta module? Let's write the signature here. Let's start with the signature here. So let's finally get back to writing AI modules. So we want a project instrumenter signature. You are an expert in writing Python code that instruments code in arbitrary languages. Okay, we want this AI module to write us basically this Python file. And if you look at what happens here, it's all about code instrumentation. It's about initializing a project in a certain language. It just so happens we've used Python because we don't know how to write anything else ourselves. It talks about the obtaining file names with a certain suffix, which for Python is .py. This file also has import statements. Well, that's what they're called in Python. We call them use statements more generally, or includes in C or whatever. It has code execution, which in Python happens with UV. In C, it will have to be pre-compiled with GCC. In Rust, it'll be cargo building, or maybe it'll be cargo run directly. In MATLAB, it'll be some way of invoking MATLAB from the console. I don't know, JavaScript, everything. And it also has a routine which writes arrays to a file. Also very language dependent, because in Python we have the equal statement and we don't use semicolons. And we can take the raw Python array, let's call it in the meta Python code, and write it as is in Python code. This is not going to work in C, right? Because C uses curly brackets for multi-dimensional arrays. It's also a jagged array. So actually, this is a pretty complicated function. In Python, jagged arrays are very easy because you can just have a list of lists, which is deceptively simple. Like AX is a list of lists 1, 2, and 3. This is a whole different beast in C, right? In C, you should do a list of pointers, and each of the pointers points to a array of different sizes. In Rust, it's a vector of vectors, again with different sizes. So yeah, we have a lot of, this is complicated, but we isolate everything in one file. So then all we need to do now, let's do it this way. Let's make a new file called templates. .py. Okay. Okay, this is how we do it, right? So templates.py will be this thing. Without the import and just with the minimal amount of static code needed. So we want an LLM to write some pieces of code for us. We're going to identify what, delete it, for example, disinitialize modules, to do, populate this. And we're going to delete this. And we're going to add a pass-through. We don't want to change the API of this function. But we do want to maybe do a bit of prompting here. For example, in Python, this would be writing init.py files in the parent folder of each file. So the AI will see this, and is there a to-do in Python? To-do command Python. There is no native to-do, right? It's just a to-do comment. Pass, yeah. Yeah, pass is fine, okay? Okay, what else? Dependency mapping. It should be a dictionary between string, list of path. This one's easier. To do, populate the correct suffix. So we can genericize this by saying suffix is dot something, and then we can say with suffix suffix. Actually, we can just do it this way then. What if the suffix is a cached property of this? Okay, and it's just called suffix self, and it's a string. To do, populate this, for example, and we add a note for the AI. For example, in Python, this would be py. That's it. Pass. Okay, so then we can just use suffix, and we don't need to touch these functions at all, which is pretty valuable, I think. Right? Yeah, exactly. Okay. And that's it. I think once this stuff is all generic because the concept of stem is generic. Of course, the AI will see it, but we only want the AI to touch these two methods, and we'll see how we do that. Actually, one of them is a basic property. It's not even a proper method. Yeah, this looks pretty good, to be honest. So I think we're getting there. Okay, more stuff. So let's see, what else do we have here? Okay, this is no longer language dependent now, which is pretty big actually. I wonder if we should split this into two. That would be really good, right? Like, well, not really, because this initialize is pretty nasty. It will need access to, definitely will need access to all the files. But then should it just not take a list of files? Yeah, there could be something here. We could actually, okay. But this is a good opportunity to see how we strongly coerce the AI to just write a piece of code inside the scope, because we'll use unified diff or something for that to detect the changes and then give feedback back to the AI. Okay, good. So more things. Now the thing is, if I break this template here, I gotta be careful to put it back here. Okay, there's a double synchronization happening here because, okay, so then for Python, this is just return py. That's it. The initialize is a bit more complicated because I just wiped it, right? What is the initialize? Oh, here it is. Okay, so we can just revert this change. There we go. Okay, good. Next up, who do we have to template? Generate use statement. I think this is just a giant to-do. To-do, populate this. For now, we can leave a note for the AI. For example, in Python, this would be a statement, an import statement built from location.parts and their stems. This is kind of all the hints we can give to the AI. There's no way we can write. Okay, let's leave another note. There's a trick here because this code doesn't to do avoid using all or star imports, rather use generic function names when they're on as a template, e.g. sum fn. So we want the AI to, because there is a trick the AI is pretty crisp in Python because it doesn't do star imports here. We actually managed to control the AI pretty well, despite we don't know what these are called, but we told the AI to just use, if we look at the template for Python, it's just a function or variable name, which actually worked out pretty well. So we want some function or variable. Okay, and then pass. We're done. This thing is really tricky because the AI will have to look inside project and use whatever info. So now there is another trickery here. Because we need to write the command. Only one piece of this function has to be generated. So to do, generate the string command, which will be executed as, populate this. Okay, note, generate the string as is by the code below. Note, the code below cannot be modified in any way. Note, if needed, use project to infer cross-file information, which will execute the file, the code in artifact path as is by the code. To infer cross-file information and generate a pre-command. I messed something up here because we also have note. If there is no pre-command, it should be none. Okay, so we can say if. So we do pre-command is none. If pre-command, we're just gonna run this. And oh no, sorry. So we'll say, okay, so result is sub process.run the pre-command. Capture output is true. Now if this fails, if result return code return pre-command execution failed with error. Okay, this is gonna get hairy here, but it's gonna be pretty interesting because, okay. And then we're gonna execute the command. Oh, okay, I see. So we don't need this. This is not valid Python code anymore, but it's fine because the AI will have to populate it in a way that is valid, okay? Yeah, this is the tricky part, actually. This is pretty tricky. All right, let's take a quick break. All right, let's see what's happening here. Okay, so we're sort of outside of the realm of valid Python code, but it's fine. The last thing we need to template is the write jagged array to file. Well, this one's pretty easy to do because we don't know how to do it. So we're just gonna have to write the jagged array to file somehow. Did we import this right? No, we did not. Very confused as to why this code ran actually. Anyway, so populate this and note this function should write the Python array. Oh, how should we say this? I guess we'll call it the global variable in the given language. Yeah, we definitely want to open, but then we want to I guess we want to populate here, all right? Yeah, in this scope. Okay. Wow, the feedback loop is gonna be insane for executing code though, because we now have AI writing code that executes. Yeah, this is gonna be pretty wild because we want the AI Can I import incorrect functions? Like if I do from stream.templates import execute code, and I can do execute code.source. How can I view the source code? Let's see. Can I view the source code of the Python function? Is inspect element, right? Use the inspect modules get source. Okay, so this works. So import inspect dot, what is it? Get source. For execute code. Okay, this works. And I can print it. And it's exactly what it is. The thing is, there are two types of language dependent. There's two types of language dependent code. It's execution related and pre-execution code. And the feedback loop for pre-execution is pretty easy because that code should be executable by itself before the AI, the main task AI, had a chance to do anything. The problem is the execute code needs okay, so we'll just go through the full validation loop. So this is what DSPy is made for anyways, right? You would hope so. So we'll have to figure out how to extract some feedback, and we'll restart this module. We'll restart both modules or something if it fails. We'll have to think about it, but yeah, okay, it is a bit tricky, but not impossible, I think. One would hope so. Okay, so then we can just do UVX rough format. Okay, nothing drastic here. Okay, let's do something else. Let's move this language. Let's make it a sub package. So what we can say is we can do in stream, let's make a new folder. No. No. In stream, I want this, right? So new folder. Oh yeah, in here. And we can call this language. Okay. And it'll have a init.py, which we need empty. Now let's cut this file and paste it here. And the same for the templates. But let's rename the language file. It's actually Python.py. Okay. The templates are templates. This should definitely not live it here now, right? Nor here. We would actually, let's make another module then. So language completed. Let's move the Python in here. You'll see why, because I want this to be a permanent cache. Like once the AI gets the code to run for a language, I think we should freeze that. You would want to store that on disk, right? So we actually want tens of these files ideally for tens of languages. Okay, so completed. And now let's make a new module in language. So templates, and this will be the thing. And this will be it's like main, but I don't want to call it main, right? Generate.py. Okay, this is where DSPy kicks in. Okay, so we have DSPy. And what did we call our class? Generate code instrument. DSPy.signature. And did we really lose that, or what happened here? No, damn it, we lost the docstring we wrote. It was pretty basic. It was something like, you are an expert in using Python to instrument code written in arbitrary languages. That's it. Okay, so now we can finally write our module. The templates is an incomplete Python file. Maybe this should not be a Py file then. It should be a .template file, which is a thing we just made up. Why is it still catching it as Python though? So I wanted to get rid of these warnings. Like not a TMP, right? And whoops, no tests. This should be called if I call it project.template, yeah. TMPs. Templates. Okay. Should be markdown? No. Let me look this up. What is a suitable file format that represents... Well, no, I need to ask Gemini or something. What is a suitable file format that represents an incomplete .py file that has syntax errors for someone to fix later? Think a sort of Python template. PYI, interface stub, all right? While recognize IDEs, defining the structure without providing the logic. Provides IDEs. It seems there is a shell file. It's valid, so if you're incomplete. Py.tmpl. Valid syntax with placeholders. Use the ellipsis or pass. What would ellipsis do here? This is so confusing. So, okay, fine. So templates.py. What if, so how should we, what if I want someone to populate a variable? None, ... Oh, this works? Oh, interesting. So I can do what? Pre-command str equals ... Huh. So command, okay. Equals ... Okay, nice. So then I can do execute the pre-command. Okay. So I have two thingies here in my template.py. Okay, interesting. I don't know about the ellipsis, which seems more elegant than none. Okay. Okay, so it seems like we have our template in order. Now let's work a bit on the, okay, we have a ton of stuff here. Actually, we need an init.py file here too. And we're done. So now what we can do is we can switch our imports. Okay, we need to finish our generate, but we can use our Python module as is. All we have to do is, not from language, from stream, well, yes, from completed.python, finally, we can import execute code. The nice thing is we'll be able to lowercase this and just change this import on the fly, right? Yup, exactly. So then also, project has ran away. I'm very confused how any of this was working, but we'll have to test this more rigorously. So it's no longer from stream. Oh, it must be cached thingies, or oh, I don't know what's happening there. From stream, it's still from language completed. Python import project. Same here, completed Python. And same here. The file adapter is genericized now, right? Yeah. Okay, same here. So from stream language, Python, generate use statement. Okay, so now the template is, oh, there's no OS. Oh yeah, there is no OS. Okay. What do we have in Python? Do we have OS here? Why? Oh, I see, because it needs, yeah, so this will have to do, so it'll be like to do, we can't, well, this guy should add imports. We'll have to figure that part out later. Before we move on to our thing, we gotta format, we got to add the whole structure. So there is no more stream language. .py. Instead, there is an add stream language. Yup, with everything it comes to. And there are a few other diffs. Okay, in the imports, write jagged array to file. Okay. Feedback. Stream project. Okay, this should be it. Rework folder structure. Now my question is this gonna work, and is there PyCache trickery or no? PyCache cleaner. Maybe we need to install this because I'm kind of freaked out about this. Yeah, I think we want this, right? No, I'm not gonna install some weird things. Instead, let's just do it ourselves then, right? So delete, that's it. Okay, and let's also do a UV cache clean, which doesn't really matter, but whatever. Okay, so now my question is, if I run, what do we run? Stream with files and feedback. It must be that the adapter was not used, right? Well, everything works, so I guess it's fine, right? Yeah, it works from the first try, which is recognizably good, because otherwise we'll have to deal with complicated feedback. But yeah, this seems to work. But it's only using the static code now, the completed code in Python. So what we like to do is we would like generate to operate on the template. Whoops. Let's see. But yeah, this is gonna be a bit trickier. Is it? So what do we want this guy to take? Well, first and foremost, it has an input field, which is a, language. Obviously, right? Which is a DSPy input field. And all we want this guy to do is okay, so this guy has a description of the language of the code to be instrumented using Python, just so we're clear. And we would like this module to take as input a template, which is Python code always, and it's an input field. And we would like it to output the code, which is the populated template in the most basic, right? So desk. So this is an instrumentation template with to-dos and notes left in. The with all completed code and no other changes. We're going to enforce this in a different way. There's a different technique called templating, which we'll have to implement some other time. But for now, this seems like kind of what we want. Yup, this seems pretty clean. But is it? There is a trickery here. What's gonna happen is I think this guy needs the project structure too. So we're gonna need a custom adapter. So at runtime. So this thing is a meta thing. So this project will always exist before both of the AIs get to do anything. And so will this signature. So what we need is, we need an initialize project here. Or it's a get project structure. Yeah, okay. Because we really, really need this to be universal, right? And this returns a project, okay? So it'll return project. Let's do it like this, right? Careful, careful, careful. Project. I think this is what we want, right? Project. Project. Ugh, this is so annoying, yeah. So it'll have to be... So what args do we need? Let's... Name, string. What else does it need? Language, string. That's it, right? Okay. So then we're gonna have to call this thing here. Let's say project structure equals, okay. Args. Args. But it is project name. I think this is it. Okay. Okay. So now we have a reusable get project thing. And this is name. Well, okay, I don't know why do we need this? We don't know. Just name. Okay, and language is just language, right? Yeah. So, okay. This does no material change. But it does allow us to use. So we do need this, right? Yeah, so we can call this get signature. And it returns, careful here because it's not an instance, it is what they call the DSPy signature, a class, right? This is how you type annotate a class. Yeah. Oh, it's type. Oh, sorry. So it's the type DSPy signature. Okay. The reason why I'm doing all this is because now I can do. It's ugly, but I can do from stream.main import get project structure. And I can say proj struct, what was it called? Proj structure. Basically the same mechanism, right? Except I don't have the args. We'll figure that out later, but finally I can do project. Project. We're gonna have to write a prompt for this too. That's the thing. And we reached the circular import now because this. Okay, we're toast now because. Okay, so this code, the templates have to be split in two. First, we want AI to populate the project by itself. This is actually universal. It has nothing to do with the other signature, okay? Once we have this, we can use, oh my God, okay, we have to dynamically import it here. So we can take a class type, actually. Okay, so we can genericize this to... okay, hang on, it's not too bad. So project class type class how to pass a class object. It's parameter in Python. Dog object. No. Passing the class itself. Yes, this is what I want. Okay, but how? And type annotate. Is it type? Use the type for the class itself. Yeah, it's type, right? Create animal instance. Dog, okay, so it's just type, okay. So yeah, this is a type What? Okay, but I need... I guess it's... We know it's project, right? Yeah. Okay, so then what we want to do is we're just going to use the project class as a literal, which works. Just has to be passed. Where else are we using it? Here? Yes. No. We know it's a project, but we have to use... So why do we want to do this? Because I'm gonna need something dynamic here, right? Because I'll rewrite the class or I'll import it from somewhere else. Okay, maybe I just want to annotate this generically then. How to generically annotate a class object, not an instance, that's passed as an argument to Python function without referring to a specific class. Oh, it's just a type. Okay, I see. So it says this is type. Okay. Yeah. Oh, it's the yeah. So it's not the type of project. It's just a type. Okay, this works, right? So project class. Is this how we... I think this is bad. Yeah, maybe... I guess it has to be like this. Okay, and what? It's type annotated as nothing now. Yeah. Okay, so now I can plug in any class. And I just have to make this work. So here I plug in project, the class. Now here, yeah, we plug in what was done. This is fine though, because we'll do from, okay. Yeah, this is getting complicated, but. So maybe this is generate. Okay, so we're gonna have to do 2 generates, and I think it's better to do 2 sub-modules. Okay, this is getting pretty hairy. I think it's good stopping point, but I hope you can see now why this is pretty interesting, because we're talking about instrumenting code in arbitrary languages with Python and dealing with files. So it all has to be carefully instrumented. And there's definitely a hierarchy here in the templates, right? First, we gotta make sure we have a valid way to manage a project with multiple files in an arbitrary language through Python. Once we have that, there's 3 more tasks we need to do. I think we may just do DSPy modules for each of these, because they're kind of wildly different. Or we can try the template approach. Maybe we do the template approach then, right? So the only thing with template approach is these should be ordered in a nice way. Maybe something like this is a more natural order, right? The primordial thing is to write the jagged array to file. This is a small self-contained task. Then generating use statements is a bit more complicated. Definitely requires this to be completed, but it will be, because we'll split these templates. Okay, so let's write this down, right? So split templates in 2. First, project, then everything else. Write 2 execution paths with 2 adapters. And I think that's it. Then we're in pretty good shape, right? If we manage to get all this. So yeah, this should be pretty interesting for next time. Yeah, thanks for tuning in, and we'll see how it goes. The feedback is going to be horrendous, but supposedly this is what DSPy is meant for, so I think it should be fine. All right, I'll see you next time.